the big idea. Some of you have already started the homework, so you probably saw what you're doing. But I'm going to make sure we got this out of the way. And then this homework isn't due until, I won't see you again until Monday. So this homework up here is all due Monday. So Friday, Saturday, Sunday, Monday, well, Sunday night. Okay, get it done. All right, so exponential function is a function in the following form. It'll be b to the x, where obviously b needs to be bigger than 0, because then what's the point if it's 0? And b doesn't equal 1 either, because then what's the point? We're just graphing a horizontal line. So when you, I think on tonight's homework, you're pretty much just graphing them. You're going to graph, like we'll give you y equals 2 to the x. They might put 2 to the x plus 1, you know, they might put negative 2 to the x. Again, all these things, this is, your parent function is this. So you just need to know what happens to it. And you can look in your calculator, and obviously, I'll put it up here. 2 to the x graph. Okay, your calculator makes it look like it stops right there. It doesn't. It's approaching the y-axis. It's approaching the horizontal asymptote at y equals 0. So it actually does keep getting closer and closer, closer and closer. It's just, your calculator just makes it look like it stopped. So, you know, looks like this. What's this point right here that it goes through? What is that point, though? Anybody know? 0, 1. Okay, and then if you shift it, it'll move and whatnot. But let's talk about things that you'll have to find, like what's the end behavior. So the end behavior is different on these. You can't just draw arrows, unfortunately. Sorry about, I know you're like, that was so much fun. I know, but now you have to actually do a little bit of work. Okay, so the end behavior is as follows. So we'll say as x gets larger, so as x goes to infinity, you actually have to do this, sorry. I'll let you say y values. What are your y values getting as x goes to infinity? They're increasing, so they're going to infinity. But as x goes to negative infinity, as x gets more and more largely negative, like negative 1,000,000, what are your y values approaching? 0. It's very important. Okay, so your end behavior is different on these graphs. The y-intercept we already, you know, talked about. When y-intercept, you plug a 0 in for x. So y equals 2 to the 0. Anything to a 0 power is what? 1. So that's why your y-intercept is 0, 1. But again, you can see that from the graph. I will ask you domain and range. You know, again, it's just things that you've got to know in this class. You just have to know these things. What's the domain? How, if I could stretch this graph along the x-axis, would it keep going? So what would my domain be? Okay. But what's my range, though? My range is usually where that horizontal asymptote is. Okay. So if it's approaching 0, like again, if this was shifted up, like if I would put +1, it would approach +1. But wherever that horizontal asymptote would be where my range would stop, and then either above, or if it's flipped, it would be then below, but this one's above. So your range in this case would be from 0 to infinity. And what else is it saying? Oh, and then increasing, decreasing. I don't know if they asked that in the beginning of tonight's homework, but I know at one point they will. But put your pencil at the end on the left. What's happening the entire time? I'm increasing. I could be decreasing the entire time, but I'm increasing the entire time from negative infinity to infinity. That means this is not applicable. There's nowhere that it is ever decreasing. So you'll have to answer questions like that, really hard stuff, right? You're crying, okay? Then you, what? Brian's crying? Stop it. Brian, the tears. I'm tired. Okay, then you have what's called the natural exponential function. The natural exponential function. And that is the function that looks like e to the x, okay? Same thing, really. It's just this special number E, which is found in accounting and things like that, when you get to do, compound interest, which we're about to get to. You'll find this number E occurs a lot. And so you just need to know this is called the natural number. There's an E on your calculator. It is located underneath this button right here in the blue. So you'd have to hit second division, and that's where your E is. Actually, I think it's different. You could actually, oh yeah, it's above the ln. It's above the ln. You could also hit second ln, and that would be, they would actually automatically give you a power. So you can do that. All right, let's just practice, graphing this one. E, by the way, let me tell you what E is. It's 2.71. 2.71. I wrote 17 in my notes. That's wrong. So it's going to look just like this. It's really going to look like what's above it. We do the same thing. And it's still going to go through 0, 1. How do I know that? Well, again, if you're talking about, let's just do y-intercept. E to the 0, you would get out still 1. So it still goes through 0, 1. The only time the y-intercept, again, is going to change if I put like a +1 here. If I put +1, then obviously things will change and shift, okay? But your end behavior would be the same, still approaching that asymptote. You're decreasing, it's not decreasing, it's increasing the entire time. Domain and range are the same. Does that make sense to you, right? This follows an exponential function. It's just called the natural exponential because it has this E. All right. So I'm not going to really go over too much more of that, but I do want to end on. Here's the. Oh, thank you. You're welcome. I do want to end on compound interest because you do have to memorize this. There are 2 formulas you're going to have to memorize. Especially if you go into business, you have to know how to do these compound interest formulas, okay? There's one called compounded continuous. Thank you. If they use the phrase compound continuous, you use A equals PE to the RT, or APERT. Have you heard us say that before? APERT, okay? Let's just go over what those letters mean so you don't get confused at all. So your P is, like, I think about it as what you put in. Your principal is what they call it. Okay, this is what you're putting in, the principal amount. The E, well, what's that? What do we just know? That's right here in your calculator, the little E button above the ln, okay? The R is the rate at which you're putting it out. The rate must be written as a decimal, okay? So if they'll give it to you as a percent, so they could say 5%, you need to convert it to 0.05. And then obviously what's time? I just said that. T. Time. T is time, and it has to be, by the way, it's always in years. It's going to change on stuff we do. So if they give it to you in months for continuous, you would convert that to years, okay? So APERT you use when they say continuous. If they don't say continuous, if they say it is compounded monthly, it is compounded daily, it is compounded annually. If they use those phrases, which we'll write down all of them because I want you to know what they mean, annual, biannual, quarterly, monthly, and daily. Okay? Then you use the following formula. A equals P times 1 plus R over N to the NT. Okay? P still means principal. R still means rate. They're still going to have to give you a rate. T still means time. But this N is what changes. The N is the compounding, meaning if I say I'm going to compound annual, then my N is 1. If I'm going to compound biannual, what is my N? Biannual. 2. Quarterly.
4.
Monthly.
13.
12. Daily, 365. Okay? You guys are about to go off to college. You're about to pay student loans, some of you. You want to look to see what they're going to compound it at. Okay? This is how they make their money. This is how the loan. If you take out a loan, if your principal loan is $80,000, what are you going to end up paying by the end of the year? Look to see how much that percentage of loan is. I think student loans right now are pretty low. They're about like 3% or whatever. They're getting there anyway. But you want to actually see if at what time, how it's compounded and whatnot. So we're actually going to do your homework problem right now, one of your homework problems together. You're welcome. You're welcome. We're going to do 302.
Yes.
Okay. So just so you can see what 302 says, I'll read it and then I'm going to move it over so we can work through it. An investment is compounded monthly, quarterly, or yearly and is given by the function. So they put a J here. It's the same as R. They're explaining what everything is. A is the value of the investment at the time. T, P is the initial principal that's invested. J is the annual interest rate. Bada, 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 bada. Given a yearly interest rate of 3.5%, an initial principal of $100,000, find the amount A accumulated in 5 years for interest that is compounded daily, monthly, quarterly, and yearly. Okay? If it would be continuous, they would have to say continuous, which actually up here it does say continuous for 301 when you choose to do 301. So let's put this together and do our problem here. This is number 302 that we're working. So when you do homework tonight, you can just say in your notes, okay? So let's see, given a yearly interest rate of 3.5%, an initial principal of $100,000. So $100,000 would come in for P. Then you would do times 1 plus your R. Your R would be the interest rate. It's at 3.5%. So how do you write that as a decimal? Okay. Your N is what's going to change. We're about to change it in a minute, but that we're going to leave that open. Your N is going to change to, if it's compounded, we have to do it a couple times, so we're going to change it in a moment. And the time is in 5 years, so N times 5. So let's do, I don't know, I'm going to make a chart here just to make it a little bit easier for me. They want N to be compounded daily. So daily would be,
What is this lead here?
it's still 365, surprisingly enough. So 365 is daily. Then they want us to do monthly, which is N will be 12. Then they want us to do quarterly, which would N would be 4. And they want us to do yearly, which is called annually, but that'll be 1, okay? So it's really just about you understanding how to put it into your calculator. Just be kind of careful how you input this in. Look, this is me having to do this because Zach Howard likes to mess me up here. Like, all right, 12/5, I'll give it to you. Everybody else was 2.5, but you were like, no, 12/5. That's all right, it was good. So 100,000, just be careful of your zeros, times 1 plus 0.035. I'm not going to put it divided by 1 because it is. And then raised to the power of 1 times 5, or just raised to the power of 5. And you're talking about dollars, guys? So what would this be? 0.63. Okay, so 118,768. This is for yearly, by the way. I worked backwards. 768.63. That's how much your principal would be worth in 5 years if compounded yearly. Okay, let's just do a few more here. Let's do quarterly. By the way, a trick to enter what you just did before, you could hit second enter. It does the whole thing again, and then you can, I know, did you not know this? Then we're going to now move this over. You can actually insert a division symbol. We're going to divide that by 4. I know, sorry, I'm now leading you into. And we're going to times that by 4. 4 times 5. I mean, obviously, I know it's 20. But now I'm doing it quarterly. Okay. Hit enter. $119,033.90 what? $119,033.98. Okay. Second enter. Now it's all in there now. And now I'm just going to replace the 4 with a 12. Oops. You can type over it, but if it's one digit, you actually have to insert. So 1, and then, whoops, second insert 2. 12, second insert 12, delete. 119,094. And how much cents?
29.
Is it 29 or I think it's 28 though I have. Okay. Ooh, what do you think is going to happen with 365? It is going to be the same but slightly higher. They want to get you for all your money when they're doing it daily. $119,123. I mean, think about it. If they do it daily for just a few people,
That's crazy.
The bank is making buku bucks. Okay, there you go. Do you know which one would be the most, though? Compounding continuous is actually the most. The E is actually more than compounding daily. Okay, but that's all you'd have to do. I mean, it's really easy. This is all like businessy stuff and whatnot. All right. The rest of the time is yours, which is a whopping 5 minutes. And this is all due